This conference will now be recorded.
So, very good evening, students. Today, we will conclude the revision part of kinematics, solving few more problems from JEE mains paper from the previous year's paper. So, I have picked up few questions. Let us first solve those. So, in this question, it is stated that a small block slides without friction down an inclined plane starting from rest. Starting from rest, that means initial velocity is 0. Now let just a minute. I actually Wacom get stuck.
This conference will now be recorded.
So very good evening, students. We'll solve few more problems on this chapter, kinematics. Uh, so here we have the problem, which is stating that a small block slides without friction down an inclined plane starting from rest. Let Sn be the distance traveled from time t is equal to n minus 1 to t is equal to n. Then what is Sn? What is the ratio of Sn over Sn plus 1? So this you have to find out. So look here. Sn means the displacement or the distance traveled, as it is said here. So we know S is equal to ut plus half a t square. So t is the time. After any time, if you want to know the distance traveled or displacement of the object, then this is the formula where a is the acceleration. So by saying inclined plane, they are trying to mean that the acceleration a is here g sine theta. But we don't bother about it because they have asked you the ratio, whatever it may be, that will be taken care. Okay. Now the point is, what is Sn? How do I write Sn? Sn can be written as, see, Sn means the distance traveled in n, like from 0 to n second during this time, minus this Sn means that particular second, like if I write S5, that means fifth second. That means at fifth second, what is the distance traveled? At fifth second. If I say S10, that means at 10th second, how much is the distance traveled? Okay, so this is the meaning of Sn. So how to find out Sn or anything like this? See, you have to find out the distance traveled during 0 to n seconds. Then you have to find out again the distance traveled by the object from 0 to n minus 1 second, during n minus 1 second. If you take the difference of that, this distance will be traveled by nth second. Okay, so this is the Sn. This is the meaning of Sn. So we can put here Sn means this t. See here, in place of t will be sometime putting n minus 1 and sometime will put n as it is given, because the object travel from n minus 1 to n. Okay, so that is the distance Sn. So let us write according to this. Since the initial velocity, see, it is starting from rest, so u is equal to 0. We have only this term. So first, Sn means half a. Let us not write g sine theta. If we write also doesn't matter. Let us go with a itself. Whenever needed, we can put this a is equal to g sine theta. So a t square. T square means n square. And minus Sn minus 1 means this. In that case also u is 0. So only this term will be there. So I can write a n minus 1 whole square. Now if you take the difference, see half a, see here it will be half a n square, then half a n square with a minus sign, with a plus sign there will be half into a into 2n with a minus sign half a, because 1 square is 1. So this 2 gets cancelled. So what we get? Half a, let us take common. So you'll get 2n minus 1. So a by 2, this is the acceleration, and 2n minus 1, this is actually Sn. So somebody can just remember this formula, just to save time. You can remember this formula. Okay, and see, we have to find out Sn plus 1 also. Sn plus 1, let me erase this part. So Sn plus 1. Sn plus 1 means Sn plus 1 minus Sn. Okay, so this is what. Here also u is 0. We can take half a t square. We can directly go with this, or otherwise you can directly put, see here in this formula, if we put n is equal to n plus 1, you should get the Sn plus 1. Let us first do this way elaborately. So half a n plus 1 whole square minus half a n square. So you can look here, n square, half a n square will go away. So you will get actually 2n plus 1 into a. So this is what you will get. So let us see, if I just exactly put this in place of n plus, see n prime now, n prime is n plus 1. So what we get from here? Sn plus 1. So a by 2, n plus 1 means 2n plus 2 minus 1. Look from here itself, you will get. So this is a general formula. A by 2 a by 2, this is 2n plus 1. Okay, see, we have got the same thing. So this formula you can just remember, Sn, a by 2, 2n minus 1. Okay, this is the formula. I am just writing here again, a by 2, 2n minus 1. Here n is the, suppose 50th second, so that is 50. 10th second, that is 10. So this is the thing. So this is the formula you should remember. Now we can just take the ratio of Sn divided by Sn to the Sn plus 1. So it is a by 2, 2n minus 1, and divided by a by 2, 2n plus 1. So what is this a? A is g sine theta, doesn't matter, this a are same for both the cases, so they will cancel each other, and finally this will be the answer. So this is very simple. If you remember the formula, then you will be able to do it within 5 to 10 seconds. Okay, so you can do that so easily. Okay, or maybe half a minute you can spend for solving this problem. So look, what is the answer here? 2n minus 1 divided by 2n plus 1. Oh, I hope I have typed, there is a typo. I hope here this will be minus. Oh, sorry, this is plus and this should be minus. Okay, so the B will be the answer. Okay, so I think there are some typos here. Either, so this will be minus and down this will be plus. Okay, so this is the answer. We'll go to the next problem. So this is a problem, again a famous problem from projectile motion. Look, this problem is looking very simple. One line problem. Okay, so a projectile is given an initial velocity. So see, the velocity is a vector quantity and it is given as vector quantity here. You can look this, if I just draw the coordinate system like this, so it has velocity along j cap direction, that means y, and x this. So this is the vector u. Okay, this is what is given. Now you have to find out the Cartesian equation of its path g, where you have to take g as 10 meter per second square. If you remember, we have solved such kind of problems, but in that case the equation was given, you have to find out the velocity and all, so those things were there. But in this case, you have been given the velocity, you have to find out what is the trajectory. So in any case we have to remember what is the equation of the trajectory. Y is equal to general formula, x tan theta minus g x square by 2 u square, sorry, 2 u square cos square theta. What is that theta? Theta is the angle that the velocity vector makes with the horizontal, and u is the velocity. This is actually the total velocity, not the component one. This is the total velocity, magnitude of the total velocity u. That means you have to find out u x square plus u y square. This is the total velocity. Anyway, you know what is cos theta, and so g is known. It is given as 10 meter per second square. So in this case, look, what are the parameters which are not known? Anyway, x, y, and here x square, these are variable. So what you need to find out, u is given, so you will be able to find out. See, u will be what? So u, magnitude of u will be, say, 1 square plus 2 square. That means root over 5. So square root of 5. U is square root of 5 means u square you will be able to get. So we have got one parameter at least. So u is equal to root over 5 meter per second that you have got. Okay. Now, but what is theta? So that is the problem. Now you have to find out what is theta. You know how to find out theta? If you know the component of the velocity, so in this case, the component of the velocity, see, uy is 2 and ux is 1. So from here, we can find out is equal to tan theta is equal to uy by ux. So during the motion of the projectile at any point, if you want to find out what is the velocity vector is making, what is the angle made by the velocity vector with the horizontal, if you want to find out that, you can just find out the component of the velocity at any place, any point, at any time, and then just take this vy uy or vuy by vx. By that, you can find out tan theta, and tan inverse of this will give you the angle theta. Now, see here in this case, uy is 2 and ux is 1. So tan theta is equal to 1. So here you have cos square theta. So cos square theta in the down, so that I can write, see, we can write this as sec square theta. Sec square theta. So I know the tan square theta, that is equal to 2, and I'll just erase this part. So this is 2. Then what will be the sec square theta? Sec square theta will be 1 plus tan square theta. We have an identity. Sec square theta minus tan square theta is equal to 1. So we get 1 plus tan theta is 2. So tan square theta means 4. So this will give you 5. So sec square theta, here we are getting 5. Now let us put all the values. So sec square theta we have got, tan square theta we have got. Let me just erase this part. Okay, so and then I'll put the values over here itself. Look, now if we put the values, y is equal to, see, x is a variable, no need to change it. So tan theta is 2, g means 10 meter per second square, 2 is anyway 2 this factor, and see, u square, u is root over 5, square root of 5, then u square will be 5. Again, this sec square theta is again 5, and this is x square. Look then what we are getting. So this is a very simple problem. The clue was there that you have to find out the angle theta. So how to do that? Tan inverse Vy by Vx or Uy by Ux. So in this case 2x minus, see, 5 goes off this, so minus 5x square. So y is equal to 2x minus 5x square. This will give, this is the actually trajectory of the, like, equation of the trajectory or equation of the path of the projectile. Okay, so here let us choose. So this is the answer. Okay, now we'll go to the next question. So this is very interesting question. This is related to relative velocities and all. So the stream of a river is flowing with speed 2 km per hour. A swimmer can swim at a speed 4 km 4 km per hour. Okay, what should be the direction of swimmer with respect to the flow of the river to cross the river straight? I have a figure. Let me explain you the problem itself first. So according to this problem, so this is a river, suppose, and these are the shore of the river. Okay, these are the shore of the river, ground. Okay, and suppose a swimmer is at this particular position, and this is, so this is a point B, which is exactly opposite direction on the other side. Okay, and here the river river is flowing, suppose the river is flowing in this way. Let us take the velocity of the river in this way. This is 2 kilometers per hour. Okay. And the swimmer can actually swim with the speed 4 kilometers per hour. 4 kilometers per hour. Then what should be the direction of the swimmer with respect to the flow of the river to cross the river straight? So straight means uh, so here the question is at what angle the swimmer should start swimming or should swim with respect to the water flow such that the swimmer can straightway go from A point to B point on the other shore. Okay, other side. So this is the question, at what angle with respect to the flow of the water. Suppose the flow of the water is this way. Okay, we have to find out, see the velocity. Let us see now. I'm just taking an arbitrary angle. I'm taking an arbitrary angle for the swimmer to start with, so that it can reach directly or straightway up to this point B. So I'm just taking theta angle, making theta angle with the direction perpendicular to the velocity of the speed of the river, direction of velocity of the river water. So let me say this is 4 kilometer per hour. With this is angle theta. So with the angle, and this angle I am just taking with respect to this perpendicular, which is like this is the direction perpendicular to the velocity of the river. So now this swimmer will have two components of the velocity. Look, two components of the velocity. One along this way, 4. I'm just writing 4 cos of theta along this direction, and along this direction it will be 4 sine theta. I hope all of you will agree with me. Now there is a velocity of the river water in this direction. Okay, so opposite to the 4 sine theta component. Now look, if this swimmer has to straightway go from A to B, then this horizontal velocity should not be there. If there is a horizontal velocity, then there will be motion along this direction also and along this direction also. Ultimately it will not reach to this point directly. It will reach somewhere here, if both the components of the velocity are there. Okay, if both the components of the velocity are there. So horizontal component, so I'll write here, to reach the swimmer straight away from A to V, the horizontal velocity must be 0. There should not be any relative velocity. Where horizontal component of the velocity must be 0. That means the velocity, this 4 sine theta, must be exactly equal in magnitude to this 2 kilometer per hour. Okay, all right, this is also in the same unit, that's why unit gets cancelled anyway. So from here, look, I get sine theta is equal to 2 by 4, that means half. So from here I can get theta is equal to sine inverse half. This is actually 30 degree. So this is 30 degree. So theta is 30 degree we have got. So this is 30 degree, but velocity, direction of the velocity of the river water is this way, right? So this is the total angle. So the swimmer has to actually travel, start swimming at an angle 90 plus 30, that is 120 degree. At 120 degree angle with respect to the velocity of the river. So here this river water, velocity of the river water or the stream of the river. Okay. So this is the velocity 120. So that will be the answer. Okay. All right. Now we have another interesting problem. So here I hope you have noted down the point that if the swimmer has to directly go to this, there should not be any horizontal velocity. That's why this 4 sine theta, the velocity component of the swimmer in the horizontal direction must be cancelled by the velocity of the river. So that was the clue. Now I have another interesting problem. So this problem states that a bob of simple pendulum, has mass 2 gram and a charge 5.0 microcoulomb. It is at rest in a uniform horizontal electric field. It is at rest in a uniform horizontal electric field of intensity 2000 volt per meter. That means this is the electric field. Okay, electric field volt 2000 volt per meter. At equilibrium, the angle of the pendulum makes with the vertical. Okay, I have forgotten to write the options. Let me write these options. Yes, so the options are tan inverse 2.0, option B tan inverse 0.2, option C tan inverse 5.0, and option D is tan inverse 0.5. Okay, so these are the options. Look, in this case, I'll just draw a figure, representative figure, and then let me try to make you understand the situation. Okay, suppose this is a pendulum. Initially, if you don't have any displacement, this is the equilibrium situation, right? This is the equilibrium situation. So at this stage, the tension of the string T and the weight of the bob will cancel each other. So this is one equilibrium situation. When there is no external force, nothing else, only the bob. Now look, the question is, if this is a charged particle, as it is mentioned here, and there is a horizontal electric field over here, then what will happen? So this is a positively charged particle, 5 microcoulomb charge is there on this, and the positive charge will be deflected in the direction of the field itself. So it will be actually experiencing a force along this direction, and its position will not be at the initial equilibrium position. It will be somewhere here, suppose somewhere here. Okay, And at this stage, suppose the pendulum, sorry, the bob of the pendulum is at rest. At this stage, it is at equilibrium. Okay, let us say, I'm sorry. At this stage, okay, at this stage it is at equilibrium. Equilibrium means there is no motion. Equilibrium, see, equilibrium is defined as, in mechanics, equilibrium, mechanical equilibrium. This is mechanical equilibrium. Equilibrium means F net net force is 0. This is the mechanical equilibrium. So look here, what are the forces? Let us first try to understand. Suppose this angle is theta. So this is the angle we have to find out. So the pendulum makes an angle with the vertical theta. Let us suppose that at this position it is in equilibrium, and see it has a velocity, force q into e along the horizontal direction. See, if this makes an angle theta, see the weight mg, this also will make an angle theta with this string. Okay, with the string. This is also theta. So it will have two components. This weight will have two components. One along the horizontal direction, like this. Not exactly horizontal, it is exactly opposite to this. So mg sine theta, and another along the string, that is mg cos of theta. And in the upward direction there will be tension, because this is fixed over here. So pendulum is fixed over here, so there will be tension in the string. So these are the forces. See how many forces? 1, 2, 3, 4. There are 4 forces. And if this pendulum is at an equilibrium, or at, yeah, so at rest, it is at rest in a uniform. It is at rest means net force should be 0. So what we can write then? So T must be equal to mg cos of theta. Okay, this is one we can write. All right, then we can write mg cos theta is equal to q into e. Okay, so this is what we can write. But one thing we have to just understand, that this t also we can just do in other way also, because see here we are just lacking of getting t, because here in this, if we do in this way, we are just not getting the value of t. In the expression we don't know the t, then we will do in other way. So this is also not bad idea, but t is not known. In that case, what we have to do, we have to do other way. We have to break the component of the t itself, so that we can just take the ratio to cancel it. So if we take the component of t, so see, if this is theta, so with vertical, this angle also will be theta. Okay, with vertical, this is opposite angle, you can see that, sorry, alternate angle. This is I'm sorry, this is opposite angle. Okay, this is theta, this is also theta. So this way there will be t sine, sorry, t cos of theta. I'll I'll let you know why that was not so correct, because t was not known. If the t was known, then we were done. But here in this case, since t is not known, we have to go with breaking the component of the tension itself. So this is t sine theta. Here it is t sine theta. Okay, this is t sine theta, which has to be balanced by QE, and t cos theta must be balanced by the weight, so that net force will be 0. Okay, now see, I can easily take ratio and I can get rid of t, the tension. So tan theta will be QE by m into g. Anyway, g is 10 meter per second square, m is given 2 gram. Q is also given, Q is 5 microcoulomb, 5.0 into 10 to the power minus 6 coulomb. Okay, and E is given as 2000 volt per meter. Okay, so QE gone. Now m is 2 gram, that means 10 to the power minus 3, 2 into 10 to the power minus 3 kg into 10 meter per second square. Now if we solve it, look, this 1 0 goes from here, 1 2 goes from here, so there will be 100 over here, and this is 10 to the minus 3, so 10 to the power, so 5 into 10 to the power, here it is 10 to the power minus 6, here it will be 10 to the power, if this 10 to the power minus 3 goes in the numerator, it will be 10 to the power 5, so you will have 10 to the power minus 1. So this is actually unitless, because this is an angle, so it is 0.5. Okay, 0.5. So if you get tan theta is equal to 0.5, I'm just rubbing it out. So if you do tan theta is this 0.5, so theta will be tan inverse of 0.5. Okay, so C D will be the correct answer for this question. Okay, so this is how you have to solve this problem. Okay, so now we'll pick up one or two more problems. See, I'll just write down in the screen first the problem, and then we'll try to solve that. So this is question from JEE Mains 2000. So this is problem number 6. Suppose a particle is moving in a circular path. A particle is moving in a circular path of radius A. Okay, A under the action of an attractive potential of an attractive potential energy given as U is equal to minus K by 2R square. So you have to find out its total energy. So its total energy is is there are options minus k by 4 square, then option B k by 2 square, then option C is 0, and option D is minus 3 by 2 k by square. So this is the problem. So how to solve this problem? You have to find out the total energy. How do you find out total energy? So this is a problem of circular motion. So one thing we can do, see, the total energy means what? So the total energy will be kinetic energy plus potential energy. Potential energy is already obtained. We can just do it here. So we have to find out the total energy. Look, let us first find out potential energy itself. So this is the nature of the potential energy. So what is the potential energy for this case? So you have to put the radius over here. So radius is A. So our potential energy in this case, R is equal to A. Okay. At R is equal to A, so this will be this. Okay. So this is the potential energy. Now you have to find out the kinetic energy. So how to find out kinetic energy? What is kinetic energy? Kinetic energy is equal to half m v square. Okay. So this is half m v square. So how to find out half m v square? See, for a central or this kind of circular motion, we can write the centripetal acceleration mv square by A is equal to the force. And this force, since it is central force or conservative force, you will be able to find out doing minus du by dr. Okay. Okay, so what is this du by dr? We can find out from here, and we will just write at a is equal to r is equal to a. Okay, at r is equal to a. After doing this, we have to write. So we'll get plus sign over here. So r square means 2k by 2 into r cube. Okay, this is at r is equal to a, it will be k by a cube. Okay, now from here we can find out at least mv square will be obtained as k by a square. Now kinetic energy is half mv square, so half m v square will be k by a square, along with half here. So what we have got? K by 2a square. Now see, I have got kinetic energy over here and potential energy as this. Potential energy we have got minus k by 2a square. Let me erase this part. So then what is the total energy? We have to sum them up. Okay, we have to sum this two up. Okay, then total energy potential energy plus kinetic energy, so which is minus k by 2a square here, and kinetic energy we have got k by 2a square. Okay, this is minus, this is plus, so it will be 0. So look, the total energy for this system or the particle is actually 0. Okay, so this is how you have to solve the problem. Now we'll take up, what is the time? Okay, I think another problem we can take up. Let me write the problem. Just a minute. We'll pick up another problem from JEE Mains itself. Okay, so okay, so I think, yeah, this is a good problem. Let me, oh, I have to just erase it. Or, yeah. The problem is a body, this is from JEE Main 2015. This is problem number 7. If a body moving in a circular path maintains a constant speed constant speed of some 10 meter per second, then which of the following describes the relation between acceleration and the radius. Between the acceleration, this is a graphical problem, and the radius. Okay, so first graph is like this. Okay, so here actually these are not up to the scale, but this is the nature of the acceleration with respect to the radius. This is suppose option A. Option B is saying r, and this is acceleration along this way. So this is like this. This is straight line, okay, parallel to the radius. Then third option is something like this. Okay, this is along this acceleration, this is r, and the fourth option is like this. So what will be the correct answer in this case? See, a body is moving in a circular motion, circular path, maintains a constant speed of 10 meter per second. Here anyway there is no values given at all, so no need to worry about the values 10 meter or whatever. It maintains in a circular motion. It is true that always the linear velocity or the speed will be constant, but the direction will change. That's why the centripetal acceleration will arise, and the centripetal acceleration in this case circular motion will be mv square by this is mv square by r. mv square by r is the force, so the acceleration is actually v square by r. Okay, acceleration will be v square by r. So you can understand that a is inversely proportional to the radius. Now then you have got, so as r increases, the centripetal acceleration will decrease. So which among these four is stating that characteristics? So that is this one. This is having a relation inverse. It is inversely varying with the radius. So this is the correct option among this. So option A will be the correct answer for this question. Okay. All right. So we'll just stop it here for today, and thus we have concluded almost. We'll have another 2 years, like we have discussed up to 2019. We'll try to pick up 2002 to 2020 these questions in the next class, and then we'll conclude this uh, kinematics part. Okay, so we'll have one more class on this kinematics. So on that day we'll pick up questions from 2020 to 2022. Okay. Okay, so Till then, bye for today. Thanks for your patience.